The year is 2025. Military powers around the world are investing heavily in robotics and autonomous systems. The idea of unmanned tanks, drone swarms, and robotic soldiers fighting alongside human troops is no longer science fiction. It's a reality that is rapidly approaching. Russia, with its long history of military innovation, is at the forefront of this robotic revolution. The country has been developing and deploying a range of unmanned ground vehicles, or UGVs, designed to perform a variety of tasks, from reconnaissance and combat support to bomb disposal and search and rescue. But how advanced are these Russian war robots? Are they the harbingers of a terrifying new era of autonomous warfare? Or are they overhyped prototypes with limited battlefield effectiveness? This essay will delve into the facts and fiction surrounding Russia's robotic warfare capabilities, exploring both the successes and failures of its programs. In 2018, Russia made headlines around the world when it unveiled a massive humanoid robot called Igorek at the Army 2018 forum. The robot, which resembled something out of a science fiction film, was shown gripping the controls of a vehicle, its metallic fingers moving with apparent dexterity. The unveiling was a PR coup for Russia, generating excitement and fear in equal measure. However, the reality behind Igorek was far less impressive than the hype. Experts quickly pointed out that the robot was nothing more than a static concept model, incapable of independent movement or action. The Igorek episode highlights the importance of separating fact from fiction when it comes to Russia's robotic warfare program. While the country has made genuine advances in the field, it has also engaged in a fair amount of propaganda and disinformation, designed to exaggerate its capabilities and intimidate its rivals. Perhaps the most well-known example of Russia's robotic arsenal is the Uran-9, a tracked unmanned ground vehicle designed for combat support and reconnaissance. Armed with a 30mm cannon, a machine gun, and anti-tank guided missiles, the Uran-9 is a formidable-looking machine on paper. In 2018, Russia deployed the Uran-9 to Syria, providing a real-world testing ground for the system. However, the results were far from stellar. Reports emerged of significant technical problems with the Uran-9, including communication breakdowns, slow response times, inaccurate targeting, and limited battlefield awareness. While the Uran-9's performance in Syria was undoubtedly a setback, it also provided valuable lessons for Russian engineers. An upgraded version of the Uran-9 is reportedly in development, incorporating improved artificial intelligence, enhanced communication systems, and other enhancements. In addition to the Uran-9, Russia has developed a range of other UGVs for various military applications. The Narekta, for example, is a smaller, more versatile UGV designed for reconnaissance, fire support, and transport. Armed with a 12.7mm machine gun or an AGS-30 grenade launcher, the Narekta can operate in both urban and rural environments. Another notable Russian UGV is the Marker robot, developed by the Advanced Research Foundation and Android Technics. The Marker is a modular platform designed for a wide range of tasks, from reconnaissance and combat support to drone launch and mine clearance. The Marker is particularly noteworthy for its AI capabilities, which allow it to operate autonomously for extended periods. The robot has been tested in a variety of battlefield scenarios, including drone hunting, urban combat, and long-range reconnaissance. Section 5. Fedor and the Quest for Humanoids. While Russia's focus on UGVs is clear, the country has also dabbled in the development of humanoid robots for military applications. The most prominent example is Fedor, Final Experimental Demonstration Object Research, a humanoid robot initially designed for rescue and combat support. In 2019, Fedor was sent to the International Space Station, where it performed a variety of tasks, including operating tools, opening hatches, and even driving a simulated lunar rover. While Fedor-ES military development has reportedly been paused, the technologies developed for the project are being applied to other areas, such as exoskeletons, AI research, and robotics for harsh environments. Section 6. Enhancing the soldier exoskeletons on the horizon. Recognizing the limitations of both human and fully autonomous systems, Russia has also invested heavily in the development of exoskeletons, wearable devices designed to enhance the physical capabilities of soldiers. In 2018, Russia began testing passive exoskeletons that allowed soldiers to carry 20 to 30% more weight without fatigue. More advanced exoskeletons are currently under development, incorporating electric motors, heads-up displays, and AI-assisted movement. These next-generation exoskeletons could significantly enhance the strength, endurance, and combat effectiveness of Russian soldiers. Section 7. Lessons learned. The reality of robotic warfare. Russia's experience with robotic warfare has been a mixed bag of successes and failures. While the country has made undeniable progress in developing a range of unmanned systems, it has also encountered significant challenges in integrating these systems into its military doctrine and ensuring their reliability in combat. The Uran 9's disappointing performance in Syria highlighted the limitations of current-generation military robots, particularly in complex and unpredictable battlefield environments. Communication breakdowns, sensor failures, and software glitches can all render even the most advanced robots ineffective or even dangerous. Section 8. A glimpse into the future. Russia's robotic ambitions. Despite the challenges, Russia remains committed to its vision of a highly roboticized military. The country's military modernization plans for 2025 to 2035 call for significant investments in unmanned platforms, AI-driven decision systems, drone swarms, and even autonomous UGV brigades. In 2021, Russia announced the formation of its first experimental robotic unit, incorporating Uran 9s, Narektas, and marker-type robots. This unit is seen as a testbed for new tactics, techniques, and procedures for integrating unmanned systems into conventional military operations. Section 9. Conclusion. A new era of warfare. Russia's pursuit of robotic warfare is a clear indication that the battlefield of the future will be increasingly populated by unmanned systems. While the reality of these systems often falls short of the hype, their development continues at a rapid pace. As AI, robotics, and autonomous systems continue to advance, the ethical, legal, and strategic implications of robotic warfare will become increasingly complex.